Mine's not working.
Just tilt the marshmallow, Charlie.
Still not working.
No, Charlie, tilt it 23.5 degrees.
Oh yeah.
There we go.
Ball, Earth, Logic. Ball Earth Logic is highly contagious. If you encounter Ball Earth Logic, immediately research Flat Earth.
This is a woman that gave birth on an airplane. This was back in October. This isn't even a new story, but I'm not going to play the video because I don't want any copyright problems. But here's another one from CNN too. It's a legitimate story, so please look it up. The story is they were going from Bali to LAX. They had to make an emergency landing in Alaska because a woman gave birth on a plane, which is kind of a cool story anyway. But there's a problem with this. This just says they landed in Alaska, but you can do a little searching to find out that they landed in Anchorage, Alaska. So if you look at that on a map, Anchorage, Alaska is up here off the coast of the tail of Alaska, I guess. It's where the water meets the land right here. That's where Anchorage is. The problem I have with this story is that if we live on a globe, flying from Valley to LAX and having to make an emergency landing way up here in Alaska doesn't make any sense. This scale down here is 1,000 miles. So at some point during this flight, supposedly when she had the baby on the plane, they had to make an emergency landing, what, 2,500 miles off course? I mean, more than 2,000 miles off course, no matter where they were, to get up there. Does that make sense to you? If we live on a ball, this has to make sense to you. Let's just say they weren't going to LAX. Let's say they were flying to Alaska. Well, when you book a flight from Bali to Anchorage, look at this. The 19-hour flight goes to almost a full day. But that's where they made their emergency landing. So they go from this. She has a baby at some point on this flight. They need to make an emergency landing. So they zip up here. I wonder how fast they landed in Alaska. I wonder how long they were actually in the air. Because if this flight was 19 hours and they had to stop prematurely, I'm assuming they were in the air less than 19 hours. Wouldn't you assume that? Would you assume that they kicked up their flight, 4 hours or so? Yeah, me neither. So in thinking about this, I looked at it in a different way. If you look at it on a flat Earth map, and you're going from Valley to LAX here in Los Angeles, Anchorage, Alaska is on the way. So if somebody had a baby on the plane and they had to stop somewhere, this makes perfect sense. Again, if you're going from Valley to Los Angeles and someone has a baby on the plane and you have to stop somewhere, wouldn't you think an emergency landing would look more like this than like this? I'm not saying this map is perfect. How would we know? The people that can get up there and look and see are lying to us. But I'm saying this makes a lot more sense than this.
This magnifying glass represents our personal atmospheric dome by which we view celestial phenomena in our world. Believe it or not, everything we see is magnified by the water particles in the air. And so we're going to start over the North Pole, which is where Polaris is, the center of the flat Earth. And you can see as we go south, even though these are circles around the North Pole, it actually creates kind of a fictitious southern pole star there as we move out from the north, which would be south. You can also see how if you were in the north, you would see the moon right side up, and if you're in the south, you would see it upside down. And as these stars do circles around us from east to west, you can see how in the south they would appear to be rotating in a counterclockwise direction as opposed to north.
We all know that the stars rotate counterclockwise when looking at the north, and so you get the confusion of people saying, well, what about the south? They rotate the other ways. Well, let's watch. You can see that they lift to the upper right, going up that wall, counterclockwise. So let's keep following that. Remember that, up this wall, up the wall. Keep rotating to the right, up the wall, up the wall. Keep going a little bit more, up the wall, up the wall. We're getting towards the south. They go up the wall. Look at that. Now they go clockwise. That's all it is. There is no southern pole star. They're all rotating the same direction. It's like a big tunnel rotating above us.
The spherical ball is actually a ceremonial pole, but because we're on a glacier here, any pole you put in the ground actually moves over the course of the year. So what we have over at the American flag is what we call the real pole. Every year they survey that to make sure it's at 90 degrees south. The spherical ball is actually a ceremonial pole. But because we're on a glacier here, any pole you put in the ground actually moves over the course of the year. So what we have over at the American flag is what we call the real pole. Every year they survey that to make sure it's at 90 degrees south. So what we have over at the American flag is what we call the real pole.
All right, move on. Nothing to see here. Please disperse. Nothing to see here, please.
Space shuttles and other space rockets arc and appear to fall back down in order to get into orbit. Sure, the altimeter never shows this arc, but that must still be the way to get into space. And I think it's interesting how the rockets have to fall to go up. In addition to pointing out this weird attribute, flat earthers have also made us aware that no one actually knows why these rockets arc like that, as demonstrated by this parent here.
Is that a plane or is it the rocket? Was that the rocket lifting off?
Yep, that's it.
That's a noise. I've never heard it before. It's drifting. That's bad.
It's doing good so far.
Is it? Is that what always happens? Does it always go like that?
Yep.
It looks bad to me. It's in space. Or is it? Is that it?
Yep, I think that's it.
Oh no, it's going down!
Well, Mark.
Peter, or Sandy, is it turning or is the Earth spinning?
A rainbow.
Sandy? It's not turning, the Earth is spinning. Sandy?
Already.
That's going straight up, it's just the Earth is turning, we're moving away from it.
This just makes me laugh because those kids are so dumb that they don't understand that the rocket only looks like it's falling because the Earth is turning. I don't understand why these space rockets look like they're falling back into the ocean, but we do know that they're in space because look at this actual NASA video of a satellite. And those dumb flat earthers say there are no actual photographs and videos of satellites in space. Boy, they're wrong.
Well, I think it looks so ridiculous and impossible. And you can tell it's real because it looks so fake, honestly.
Tell me your name.
Ruth Heath.
Ruth, and how old are you today?
102.
102. So you were born in
1918.
1918. And we were just talking, and I asked you what shape the Earth is, and what did you say? What were you taught in school in elementary school?
I was taught in school that the Earth was flat.
And then what do you remember when they changed it to a globe?
Well, when they changed it, I remember when they changed it, but I can't remember the date or anything like that.
And did you believe them?
Yes, I did.
You did. Now,
I was young.
Right, and we all were told by people that we trust.
That's right.
Where did you go to school? Elementary school?
I went to Spur Glen School in Hamden, Connecticut. I lived on a farm and grew up with all kinds of animals. No electricity. A big white farmhouse.
You said that you're religious, that
yes.
you follow the Bible.
Yes, I do.
And are you aware that the Bible is all about the flat Earth? That God put the Earth on the footstool and separated the waters from the waters, and created the firmament. If you read Genesis, there's over 200 verses in the Bible that refer to a flat Earth.
That's right.
And I think there's only one verse that mentions Earth as a circle. But just like this table right here, that table is a circle,
right?
But it's flat.
That's right.
Right. A circle is different than a sphere. A sphere is the same in every direction.
That's right.
The circle of the Earth. So how does it make you feel to realize that you were right as a kid?
It makes me feel better.
It does make you feel better, right?
Oh, it makes me feel alive.
Oh my God, that is so true. My whole life, I believe,
yes.
What I was taught.
That's
and then
right.
when I discovered the flat Earth,
I feel better about it.
Because we are the center of creation.
That's right.
We are important.
That's right.
We are here.
We are God's children.
Excellent.
Yes.
I will,
I believe in God. I trust God. And when all the problems that are happening in this world today.
I'll give you some good news. A lot of the problems that they report on the news aren't even real.
That's right. That's right.
They're just keeping us in fear.
Keeping up. That's right. That's right. That's right. I understand that. They just say what they want people to know. They don't care about the Bible. They don't care about life. They only care about I, me, myself, and I. It's a different world.
So the globe deception that a lot of people say, and I believe, is literally by Satan to hide God and make people selfish and self-centered and not care and think that there's no consequences for their actions.
Right. I pray every night before I go to bed. And one night things weren't happening right. And I sat up in bed and I said, God, where are you? I need you right now. And I'm beginning to wonder, where is God?
God's right above us in the clouds. The heavens are right here. That's all that there is. And there's not infinite space. Did you know, wait, let me ask a question, just switching topics a little bit, that we never went to the moon, that was all fake?
Is that right?
That's correct.
I saw that all happening.
Yeah, so did I, and we all believed it, but that was just to reinforce that people to believe they can live on a ball and they could walk on a ball. Nobody's ever been to space because space doesn't exist. There is no space. There's just this world.
Oh, it's such a lie.
It's such a lie, but knowing the lie is like going to a magic show.
I woke up.
Yes, that's what we call it. We call it red. This is your moment of waking up.
Oh.
It's when you go to see a magician and you know how the tricks are done, and the magic no longer works on you, and you're free from the illusion. So knowing this is going to free your heart.
Cry.
Yeah, that's okay.
It makes me cry.
Happiness.
Yes.
Tears of joy.
Yes. Yes. I know that we were true, and they're hiding us.
Yes, it's good though.
It's good.
It's very good.
Yes.
All right.
I'm awake.
Yes.
I'm awake.
Awesome. Thank you so much.
That's my pleasure.
All right.
It's my pleasure to know that it's true.
It is absolutely true.
Oh, it's amazing.
Here's the thing: if you tell other people that aren't awake, they'll think you're crazy.
That's right. That's right.
That's their problem.
No, I believe it. I believe it.
Yeah.
Oh.
So good, right? I'm glad we met.
I'm so happy.
That's awesome.
That's awesome. It's right.
All right, I'm gonna, this is what I did. I was visiting my mother, and I asked who the oldest, most lucid person was, and they introduced me to Ruth. Ruth, right?
Yes.
And
right.
I encourage anyone else that has access to an old age home to do the same, because there's not many people like Ruth left that remember these things. Amazing. All right, Ruth, thank you.
Thank you. I'm amazed. I'm so happy to know it's true.
It's true, and God created this world.
Yes.
And He's right here in the clouds above, close, not in an infinite universe. So good, right?
I can't get over it. Made me cry.
Made me cry too.
Yeah. Thank you. Thank you.
All right, Ruth, give me a hug. Here we go.
I need it.
All right.
Thank you.
All right, bye-bye.
In this video, we will be explaining how incoherent electrostatic acceleration creates the downward vector. Gravitation, a word which many do not comprehend, is a theory that was created to explain the paths of the luminaries above and what keeps them in orbit around other bodies, including our Earth. It has been known and taught in college-level physics courses that the electric forces that hold the Earth together are 26 times stronger than the gravitational forces that are supposedly here on Earth. I will now show you a short video of former MIT physics professor Walter Lewin explain this quite clearly.
So what holds our world together? Well, on the nuclear scale, 10 to the minus 12 centimeters, very important are the nuclear forces. On an atomic scale, up to thousands of kilometers, it's really electric forces that hold our world together. But on a much larger scale, planets and stars and the galaxy, it is gravity that holds our world together. And now you may say, that's very inconsistent with what you just told us, because didn't you tell us that D cancels if you compare gravity with electricity?
Yes, but keep in mind that most objects in the universe have only a very small amount of charge per unit mass. The Earth and Mars have each a charge of about 400,000 coulombs. The gravitational force between them is therefore about 17 orders of magnitude larger than the electric force.
So even though our immediate surroundings are dominated by electric forces, including your own body for that matter, the behavior of the universe on a large scale is dictated by gravity.
As you heard the professor state, gravity does not take place until we start talking about a moon orbiting a planet, the planet orbiting a sun, or stars orbiting the center of their galaxies. I fully agree that this is a theoretical concept that is unproven still today, and find it odd that they need ideas such as dark matter to make up over 90% of their model to explain how it is possible. Having said this, I completely understand people's reluctancy to use gravity in any kind of discussion about the place we live. At the same time, most people who have never been educated on the subject correctly believe that the force holding things in orbit and the force making things fall are one and the same, in which lies the problem. It is hard to explain how this place works when most do not know how the laws of electricity control the world around us. I will try in this video to explain how incoherent electrostatic acceleration works while using examples that can be recreated by anyone. To start out, we will take a look at Earth's electrostatic field. This is important because we, along with all the matter in this known realm, are inside of an electrostatic field. The Earth itself has a measurable negative charge compared to the air above it all across the plane. As soon as you leave the surface, there is a positive charge in the air around you that grows in electrostatic potential the further you go up towards the sky. It is a steady, gradual rise in potential, which tells us, according to the laws of electricity, that we are between two Gaussian surfaces. A Gaussian surface is simply a surface that encloses or distributes a charge. If there were only one surface, the rate at which the positive potential grew would be different. Knowing that we are between two Gaussian surfaces, we can also know that certain phenomenon will take place in all matter within the electric field, or area between the two surfaces. For this topic, we will first look at polarization through electrostatic induction. Electrostatic induction is a phenomenon where the positive and negative static charges on matter are slightly separated or polarized due to the electrostatic charge of its surrounding area. If one set of the object's surroundings is positive and the other negative, the negative charge on the object will be attracted to the positive area around it, while the positive charge on the object will be attracted to the negative area on the opposite side. So here on Earth, the positive charge on our bodies is always attracted down towards the Earth, and the negative will be attracted to the air above. This phenomena creates a slight force in that downward vector, because as soon as we leave the ground, we start becoming positively charged by the air around us and are now forced towards the negative of the ground. This is electrostatic acceleration. One might think that the attraction from above and below would cancel out completely, but it is the electrostatic gradient that creates a flow from the positive above to the negative below. Think of the Earth as a flat strainer, and there is a constant flow of water from above, moving very slowly, always applying a force in a downward direction. This would be considered a vector. The electrostatic potential difference getting stronger as you rise from the Earth will keep a steady pressure from above at all times until it reaches the Gaussian surface above. When we reverse the polarity of the electric field and put a negative surface above a positive one, we can reverse this electrostatic phenomenon and get things to stick to the upper plate as if it were the ground. This works with all types of matter. You can move wood, iron filings, and even human hair with these forces. Believe it or not, you can even get water to bend. If the vector lines created between the two Gaussian surfaces are curved, all the matter will follow these field lines as well. In this demonstration, instead of using a flat plane, I use two circular objects as my Gaussian surfaces. You can see that as the water settles after being sloshed around by me turning the wheel on the Van de Graaff generator, it comes to rest with a curve in the surface following the electric field lines between the two spheres. This is why the ionosphere, a phenomenon that has never been created in a lab, is a theory yet to be verified, but is needed to create this phenomenon here on Earth. Maxwell himself changed Ampere's law, which stated plainly that without matter, no electrostatic field can exist. Maxwell changed it with no scientific evidence, allowing it to gather magically above our heads in free space. Density and electric potential go hand in hand. The denser something is, the more electric potential it can hold. Not that I believe in the model of the atom, but even the periodic table has a distinction on the amount of electric potential there is in the different elements. In this demonstration, I have a metal button hanging from helium balloons that keep the button buoyant just above the ground. By only adding more electrostatic potential to the button, you can see it will appear heavier and force the buoyant object down along the vector lines created by the electrostatic potential difference. Without changing the density of the medium or the object, one can change the overall weight or gravitas of the object. To do an actual experiment on the topic of gravitation, this variable of electrostatic acceleration must be taken into account at all times. Now we will take a look at how different electric potentials of gases act in this electrostatic medium we live in. Gases have different electric potentials, just like all matter does. The gas molecules that can hold more potential than those gas molecules around them are theoretically more dense, and will have a stronger attraction towards the negative ground below. When these gases are carried along the downward vector by these electrostatic forces, the lighter gas gets displaced and becomes buoyant until it finds a place with the same electrostatic potential. This is why we have a pressure density gradient and are told the noble gases work their way up into the higher elevations and collect in layers above. This has not been verified by anyone I know, so at this point I cannot say if this is true or not. Through this induction, some pretty amazing things happen when large electric potential differences are applied to gases. When gases are placed into an area with a strong electric potential difference, we get the phenomenon known as ionic wind. If a person were to charge themselves up with 1 million volts of static electricity, they could blow out a candle almost 2 feet away from the gases rushing away from their fingertip because of the exceptional potential difference. We do know that when a gas loses its electric potential, it slows down so much that it turns into a liquid, like the condensation that forms on a window when it's cold outside. The gases hit the cold window and transfer their potential energy to it, trying to mediate the temperature. In doing so, the gases lose their electric potential and turn into a liquid. Down here near the surface, the system is very dynamic, with all the plants and animals breathing, low altitude weather patterns constantly cycling, and Earth releasing gases from the deep at all times. We will never see all the gases lose their potential and turn into a liquid anytime soon, I hope. Now we will get to the incoherent part of the phrase. It is called incoherent because it is not completely polarized, like a magnet, but only slightly on its surface through electrostatic induction. A magnet, with all of its potential stored on opposite sides, would be considered coherent. Now these forces are very weak, and only apply a slight pressure along the vector they create. All other pressure mediations, such as buoyancy, atmospheric pressure, and temperature, are certainly stronger, but nonetheless, these weak electrostatic forces are ever present in the world around us, and I fear the day they may come to an end. Again, I fully understand people's reluctancy to use the word gravity when speaking of this place we live. So instead, let's call it what it really is: incoherent electrostatic acceleration. Let's teach those just finding out the nature of this world in which we live the correct way. The fact that we live in an electric realm with a static electric field you yourself can go out and measure tells us without a doubt that these well understood laws of electricity create the downward bias phenomena we witness all across the plane. Instead of using the word gravitation, I ask you to educate yourself further on incoherent electrostatic acceleration. This is Good Times for All here, signing out. As always, thanks for watching.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes.
Science is all about testable, observable, and repeatable data, right? So to alleviate the problem of distorting the edges because the magnifying glass ring is too small, I went on Amazon and I got these plastic magnifying sheets and came up with another way of doing the same thing, using the sheet right here. Set the city up, a little cutout of the city, and now I've got the big magnifying glass sheet. Bring the camera right up to the lens. See, that's the normal view of the city. Now let's back up again.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here,
The atmosphere really is acting like a lens.
yes.
Atmosphere really is acting like a lens, and this is how much of the city is missing due to the lensing effect, the magnification of the atmosphere. You're missing, a good portion of the city just by pulling my iPhone back on a 3-foot long desk. That's how much I lost of the city. We're all the way up against the glass. Now let's zoom across the lake. And wow, look at that. The lower portions start to disappear. Now let's zoom back in to get a little closer to the one that Captain Baltard was talking about here. And wow, look at this. Here's his image on the right, and here's my image on the left. Missing the lower portions of the city had nothing to do with curvature whatsoever. And this, of course, is my answer to the meme that you've all seen being passed around on Facebook showing the missing part of buildings is absolute proof of the curve. No, not really. But, okay, here's the part I really wanted to show you guys. I was already in the process of modifying my experiment, so here's what I came up with. I've got my magnifying sheet frame, and I created a little stand to paste the sun on it and keep it the same height over the flat surface of a table. So the sun is always going to be parallel with the surface. And check this out. All right, here's the first test of a sun moving over a flat surface. And with no atmospheric magnification, it does what we might expect it would. It gets smaller as it goes away from us. All right, now let's see what happens when we add in our atmospheric magnification. Again, water and refraction. Water causes magnification and refraction, right? So let's bring the sun back. Oh, check this out. Refraction bends the light downward. It made the sun set on a parallel surface as it was moving parallel, the same height, the whole way over a flat surface. The refraction caused the sun to set. Not only that, well, let's bring in the beginning of that little test, and we see that it maintained pretty much the same size, too. Pretty close. And of course, that's because as it's moving away, the magnification is still taking place. And so even though the sun's further away than it was in the beginning of the test, the magnification basically preserved the same size, and the refraction made it set. Now, I'm just going to put forward a crazy idea for you to think about. And that is, if Rob Skiba could figure this out, I'm just going to go out on a limb here. I think it's quite possible that the creator of the cosmos could have figured out the same thing and engineered our beautiful sunsets, thanks to all that water he placed in our atmosphere. Just something to think about.